Okay, so the next section we're going to cover is section 4.8. And really this section is just kind of an additional problem set section. We'll be seeing some real world problems. We're also just going to talk about what it means to completely solve a triangle. So we're just going to use some trig in order to calculate a couple of different examples. To start off with, let's talk about what it means. Actually, let's talk about what it means to just solve a right triangle. Or solve any triangle, really. So let's just say here is my triangle. I have this angle is about 16 degrees. It's a right triangle, so that's good. And then that side is 14. So when we're saying solve the triangle, what we really mean is to find all missing sides and angles. So in that case, that means we're looking for this side, and then this angle. So just to make it so that I have something I could actually solve for, I'm going to call this x and then this one y, and I'll call this angle up here capital A. Okay. So there's a few different ways to solve this. Most of what we're going to be doing is using trig functions. But a couple other options that we'll be using, one of them is that the sum of all angles in a triangle is 180 degrees. And then another formula or fact we're going to be using is the Pythagorean theorem. So we're going to kind of be using all of these, but really the big one that we'll be using is the trig functions. Okay, so initially, let's just say I want to solve for x. Let's see if we can do it. Now I know that sine of an angle is the opposite side over the hypotenuse. So I actually could solve for x in this one right away. Excuse me. Because all I need to do is move that 14 over. So 14 times sine of 16 degrees should give me x. So I'm going to plug that into my calculator. And I get about 3.85 and some other stuff. So let's round to 3 decimal places. Let's say it's 3.859. Excuse me. Okay. Similarly, we can solve for y right away. Except now we'll use cosine. And so 14 times cosine of 16 is about 13 point, I'll write it down, 13.458. Okay, so we have x and y, that's good. Now there are other ways to do it. We could have used the Pythagorean theorem to solve for y. We could have used some other angles. But I now have those answers. So now we can solve for a. Again, a couple ways to do this. I'm going to use the fact that the sum of all the angles equals 180. And so that means that A is going to be 74 degrees. You could have used inverse trig functions to do this. You could have done a like a cosine inverse or sine inverse to get it, but you don't really need to. So now we're done with that one. Okay, let's try another one. I know this is probably pretty straightforward, but let's do another one just to see another type of example. Solve. Okay, so in this one, I'm going to call this side 5 and this side 8. So what we need to do is we actually have to solve for two angles in this case. I'll call those A and B. And then I also have to solve for this side length over here. So I'll call that X. Now notice we don't really have, we can't just do sine of some angle, for example A, because this would give me 8 over X, and there's too many unknowns in this equation. I could try doing tangent of A, because that would give me 8 over 5. So this is actually good because this is an equation with a single unknown. However, to solve this, we're going to need to use some stuff that was just covered yesterday. And we're going to need to do tangent inverse of 8 over 5. So I was just kind of playing around to see what formulas I could come up with. And we came up with this one, which doesn't help us with any side lengths. It doesn't help us find X, but it does help us find the angle, which is nice. So let's go ahead and plug that into the calculator. Tangent inverse of 8 over 5 is about 57.9. I'll just round that one to 58. So A equals 57.9946. So we'll say that's about 58 degrees. Now I could continue with this. I could actually do the same thing for B. I could do tangent of B equals 5 over 8. But I think it'd probably be easier just to say that the sum is 180, because we now have two angles. 90 plus 58 plus B has to equal 180. So that means that B actually equals 32. So B is 32 degrees. I should probably use approximate here since A was approximate. Okay, so now what we could actually do is we could go back to this original here, and we could actually say that sine of 58 degrees has to equal 8 over X. And now we could actually solve for X. X would be 8 divided by sine of 58 degrees, whatever that might be. So let's go ahead and do it that way. You might have an alternate method, which I'll come back to. So let's go ahead now. I'm going to say 8 divided by is about 9.433. So we'll do 3 decimal places again. I will try to always be explicit about how many decimals I want. In this case, it's 9.433. An alternative method, and maybe you already saw this even before I started the problem off. Notice we have two sides. We have the 5 and we have the 8. And to get the third side, we could just say, well, 5 squared plus 8 squared has to equal X squared. Which means that 25 plus 64, so 89, equals X squared. Which means that X is approximately, hopefully it's about the same. Might be a little bit off due to rounding issues. So I get 9.434. So a little bit off, but that's okay. So this was the Pythagorean theorem. Okay. So a lot of different ways to do it. You can absolutely use trig for pretty much all of this, but I would also encourage you to remember the other strategies that you might want to use. So in this one, we just use kind of regular trig to do it. In this one, we had to use inverse trig to find the angles. But either way, you do have to use trig, and so those are some strategies. In the next videos, we'll look at some more real-world type problems.